All right, 1.5, solving quadratic equations. What we're going to do here is we are going to solve quadratic equations very similar to what we did in previous years of math in grade 10. But here we're going to spend most of the time just going over the idea. A quadratic equation can be solved by completing the square. So we solve it by completing the square by getting the quadratic equation into vertex form and then solving for x. We'll see examples of that later on in this course. Second part, we can solve by factoring. Third part, we can solve by using the quadratic formula. And if we have a graph, we can actually have the graph help us solve the quadratic equation. To solve a quadratic equation means that we're looking at the x-intercepts. So the number of solutions to a quadratic equation and the number of zeros of the related quadratic function. So whether we say solutions, zeros, roots, x-intercepts, it means the exact same thing. Okay, these can be determined, the number of them can be determined by looking at the discriminant. What is the discriminant? Well, folks, the discriminant can be found in the quadratic formula. If in previous years I've talked about stating the quadratic. The quadratic is a wrap to remember the quadratic formula. The quadratic formula is as follows: x equals negative b plus or minus square root b squared minus 4ac all over 2a. One more time, that's right. X equals negative b plus or minus square root b squared minus 4ac all over 2a. If you do this quadratic 10 times, you will remember this formula. This formula, the quadratic formula, is important when we need to solve. So we can use the quadratic formula to solve for certain equations. Now the discriminant is found under the root sign in the quadratic formula. So this part right here, b squared minus 4ac, is actually the discriminant. It helps us find the number of roots. So let's look at how it does that. b squared minus 4ac, when that value, that number, is greater than 0, what we can say is that the graph actually, when it opens up, touches the x-axis twice. Once, twice. If the graph opens down, it touches the x-axis twice. 1, 2. So it doesn't matter where it touches. The fact that the discriminant is greater than 0 implies that it touches it twice. So we can use that information to tell us that we need 2 answers, 2 solutions, 2 roots. Now these are real roots, mind you, folks, so they have to be real. They really touch the x-axis twice. And finally, it is that the parabola crosses the x-axis twice. All right, what about when b squared minus 4ac equals 0? What happens then? Well, you'll have an axis, and the parabola will open up or down, and it will touch the x-axis once. There's one solution, one real root, folks, one real root. The parabola crosses that x-axis once. Some people might say that there are 2 equal roots. I want you to think about the equation and remember that the equation implies that when you get the actual equation, you will find out that there's only one root that appears twice in the factors. So you're going to see an example of that. So some people call it 2 equal roots. Well, 2 equal numbers equals 1 real root. It touches the graph once. It touches the x-axis once. Now, b squared minus 4ac is less than 0, means that the graph actually doesn't even touch the x-axis. Okay, the parabola will not touch the x-axis. That means that the number underneath the root sign would be negative. And when you try to take the square root of a negative number, your calculator will not be able to evaluate that answer. So there are no solutions, no real roots. And the parabola crosses the x-axis never. Okay, so basically it never crosses the x-axis. It never touches it. So therefore, because it never touches it, okay, whether this one or this one, it never touches it, there are no real roots. All right, moving forwards. Let's look at an example. You're asked to solve by factoring. So although some of you may be tempted by using the quadratic formula, sometimes you're forced to do it by factoring because you're told to. So how do we factor? Well, when we look at the question, this is called a simple trinomial. All right, there is a 1 in front of here. The 1 and the negative 12 get multiplied to give us negative 12. What two numbers? Multiply to give us negative 12 and add to give us 1. That is x minus 3 and x plus 4 equals 0. What this means is that when I expand this out, I will get x times x, which is x squared, x times plus 4, which is plus 4x, x times minus 3, which is minus 3x. So you will have plus 4x minus 3x, which is going to give us x, which is right here, and minus 3 times plus 4, which will give us minus 12. How does that help us? Well, now we can determine the roots. What is the solution for this? When you're trying to solve by factoring, what you're implying is that one of the two brackets multiplied will equal 0. That means that one of these brackets has to be 0 in order to equal 0. What value of x, if we plug it in here, will give us 0? What minus 3 gives us 0? That number is 3. Over here, what plus 4 gives us 0? That number is negative 4. So our answers to x is negative 4 and 3. Now keep in mind, when you do a solution, you need to have the numbers in order from lowest to highest. Think of it when we list the domain. When we list the domain, we list them from left to right. The same values here. We list them from left to right. Something else to note when you look at this, I want you to see, is that when you factor and you find the roots are always going to be opposite of what you see inside the bracket. So you see minus 3 in the bracket, the root will be 3. You see plus 4 in the bracket, when you bring it out, it becomes minus 4. So that's going to be something important that we see throughout the course with brackets and numbers. Now, what's important on the second part is that you need to determine the product and the sum. The product, folks, is negative 18. Negative 18 because it's 3 times negative 6 is negative 18. The sum is negative 7. What two numbers multiply to give you negative 18 and add to give you negative 7? Well, that's going to be negative 9 and positive 2. Why is that the case? Well, I want you to think about negative 18 and negative 7 will give us negative 9 and positive 2. Negative 9 and positive 2, we have to be able to get from these numbers that are here. Remember, when we expand it, it must equal the original question. So I got 3x and x. Where did I get 3x and x from? That's usually a question that people ask. Well, 3x, remember that 3x and x has to equal 3x squared. Remember, the front has to be 3x squared. The back is going to be negative 6. Somehow, I've got to get negative 9 and positive 2. I have 3x here. What can I multiply 3x by so that I get negative 9? And that's right, folks. You would get a minus 3 over in the other bracket. So that when I do an outside, inside check, you will see negative 7. Watch and see. 3x and negative 3 gives us negative 9. So now we do an inside check, and what do we need? We need positive 2. Remember, we have our negative 9x. We need our positive 2x. And this number over here is going to be, that's right, plus 2. Okay, one more time. We want to expand this to equal this. To do that, we take 3x squared times x is 3x squared. 3x times minus 3 is going to be negative 9x. That's outside. Inside is plus 2x. So we have negative 9x plus 2x gives us negative 7x. And finally, plus 2 times negative 3 is negative 6. So the entire equation is still 3x squared minus 7x minus 6 equals 0. But when we factor it, it looks like this. If you need some more review on this, check out the 2D videos that involve factoring that spend a lot more time learning how to factor. Now, 3x plus 2 turns into, when we want to find the 0 of this, okay, we're going to look at that in just a second. Actually, I'm just going to go through and state some review points. First of all, when you factor, this is important to note. If the original question does not have common factors, each of the individual brackets will not have common factors. That's important to note. The next part, always do an OI check. And even if you already know that 3x and x give you the 3x squared, and you know that plus 2 and minus 3 gives us the minus 6, always do an outside-inside check. That's an OI check. Outside is negative 9x. Inside is plus 2x. That gives us our negative 7x. It will actually equal the middle number. So it's important to see that the middle term matches. Now, back to the zeros. What will the zeros be for this? Well, they will be x equals, now in order, negative 2 over 3, and the second one will be 3. So negative 2 over 3, how do we get that? It's the opposite of this number divided by the number in front. So negative 2 over 3. This one is 3 over 1. So it's just 3. So those are the roots or solutions for this particular quadratic. Moving forwards. Example number 2. You're asked to solve using the quadratic formula. Give exact answers only. So we're going to look at exact answers, folks, and what's expected as a solution to make sure that you do this correctly. So 6x squared plus 7x minus 3 equals 0. And B, 6x squared plus 14x plus 6 equals 0. We need to solve for x. So A is equal to 6, B is equal to 7, and C is equal to negative 3. We have to plug this into the quadratic formula, so let's list it. X equals negative b plus or minus square root b squared minus 4ac all over 2a. Now I've listed it here for you, but folks, honestly, as long as you list the a, b, and c and plug in the values, I don't even need to see the quadratic formula. But you see, once you see the quadratic formula, you plug in the values for a, b, and c, and what the next step, in order to show that you demonstrate your understanding, we need on the next step to show the discriminant value. So you're actually going to write negative 7 plus or minus the square root of 121 over 12. By showing the discriminant, what you're doing is showing your work. It's a way to show your work, okay? And it helps you be able to consider, try and do this mathematically, because sometimes you'll be encountering courses that don't allow a calculator. So show the discriminant. Next, because the discriminant is a perfect square, we can take the square root of that. So we'll have negative 7 plus or minus 11 over 12. Remember that 11 is not the discriminant. 121 is a discriminant. It's the number found under the root sign. So we have 11 here, and what we're going to do is add and subtract the top numbers, then divide by the bottom and reduce to get our root values. So, notice that the roots are not in order, so make sure you write them in order. -3/2 and then 1/3. And that is the answer to part A. Let's look at part B. So we know our A, B, and C values. Plug them into the formula. Show the discriminant. Then once you show the discriminant, this is an entire radical. The next step is to simplify this entire radical. Show me that step. Show me how you're going to simplify it. Root 52 is 4 times 13. Once you've done that, you can then now show that the entire radical as a mixed radical. Once you do that, you should say, okay, I'm almost done. Or I might be done already. But be careful. Sometimes you can reduce your answer. So notice that the top and the bottom both have a 2 that can be taken out. So when I divide 2 from both the top and the bottom, I end up getting -7 plus or minus root 13 over 6. And that will be the answer there. All right. Example number 3. Use the discriminant to determine the number of roots. So we're going to use the discriminant to determine number of roots. Sometimes you'll be asked to just determine the number of roots. You have to remember that you use the discriminant to determine the number of roots. Not what the roots are, folks, but how many roots there are. So in the first one, our A is 5, B is -4, C is 7. Plug it. The discriminant is b squared minus 4ac, so we plug it into there. And we find out that that discriminant is, now some of you are trying to pull out your calculator and do this, but you don't need, it doesn't ask for the discriminant. It says use the discriminant. So I don't need to see the discriminant, but I need to know something about that number. Is that number greater than 0, less than 0, or equal to 0? And in this case, it's actually less than 0. So what does that mean? Well, we can make a statement. Therefore, there are no real roots. Now remember, I allow you to use the word real or the symbol, the real symbol for root. That's fine with me. Next, 3x squared minus 3 is equal to 0. A is 3, B is 0, C is -3. Why is B 0, you might ask? Well, notice here. In these, there are 3 terms. Here, there are only 2 terms. What happened to the third one? Well, the third one is B because there's no x here, so B must be 0. So, plug it into the discriminant formula, and we find out that the answer to this is going to be, oh, some of you might be fooled. You might think that this might be a negative number again, but it isn't. It's a positive number. And because it's a positive number, we find out that there are 2 real roots. If you don't believe me, type that into your calculators, folks. I guarantee it's positive. Next, A is equal to 1, B is equal to -4, C is equal to 4. Plug it in, B squared minus 4ac. And you plug in the values, and guess what? Lo and behold, you end up with a value of exactly 0. What does that mean? Well, we have 1 real root. And again, remember you can use the real symbol instead of the word real. Moving forwards. Example number 4. What value or values of k, where k is an integer, will allow each quadratic equation to be solved by factoring? So here's our first one, and here's the second one. So let's reread the question. It says, what value or values of k, where k is an integer, will allow each quadratic equation to be solved by factoring? So basically, we have to figure out all the possible numbers that will allow us to be able to factor this equation. How do we do that? Well, we know that the product is 12. So think of all the possible factors of positive 12. And those are 1 and 12, 2 and 6, 3 and 4. Now, some of you might be going, okay, so I just add those up, 1 and 12, and that gives us 13, which is great, but you forgot a more important part, and that is the fact that it's not just 1 and 12, but positive 1, positive 12, and -1, -12. So the answer to k is plus or minus 13, because remember k is an integer. K is plus or minus 13, plus or minus 8, or plus or minus 7. So this is the answer that I'm looking for. Next one. Or these are the answers. So there are 6 possible answers for k. Interesting. Let's look at the next one. Try the next one by yourself. Stop the video now and try that question. Okay? All right. Welcome back. Think of the factors of -15. What are they? -1 and 15, -3 and 5, and calculate the all of the possible values. So -1 and 15, -3 and 5, but wait a minute, guys. Those 2 work, but you might have forgotten another part. You might have forgotten that it could be +1 and -15, or +3 and -5. So don't forget that the k values have multiple possible answers. In this case, there are 4 possible answers, plus or minus 14 and plus or minus 2. All right, one more question. Example number 5. You're asked to find 2 consecutive whole numbers such that the sum of their squares is 265. This is another thinking type question and involves trying to understand what it's saying. Find 2 consecutive whole numbers such that the sum of their squares is 265. Well, if one number, let's say x, what would the next consecutive number be? That would be, that's right, x plus 1. So we have x plus 1. Now squares of those, so sum of the squares of 2 consecutive numbers is 265. And don't forget to write your let statement. So let x and x plus 1 be consecutive numbers. And what's more important now is we have set this equation up. We can now expand it. X squared and x plus 1 all squared is x squared plus x squared plus 2x plus 1 minus 265 equals 0. Now what you're going to do is collect like terms and find the value of x, all the possible values of x. Because it's a quadratic, we have up to 2 possible answers here, folks. Now, the next step is to recognize that there actually is a common factor. What is that common factor? That's right, you could take a 2 out of the equation. That 2, when you take it out of the equation, stays outside. And the beauty of that x staying outside is we can now factor what's left inside. What 2 numbers multiply to give you -132 and add to give you 1. Again, what 2 numbers multiply to give you -132 and add to give you 1? Those are +12 and -11. So, what are the values of x? Well, they are -12 and +11. Here's the thing. How come I'm ignoring -12? Sometimes we get to ignore numbers. Why -12? Not because it's a negative. That is, it is because if you look up here, it's asking for 2 consecutive whole numbers. Whole numbers are numbers that you can count on your fingers, including the number 0. Okay, so 0, 1, 2, 3, 4, 5. So -12 is actually a negative number. So, because it is not a whole number, so that's a double bar W. Remember in a previous lesson I talked about the double bar W. Therefore, the numbers are 11 and 12. Not -12, remember. It's 11, and then the next number is going to be 12 because it's consecutive numbers. All right, folks, that's the end of the video. Have a numerical day. Take care.